Well, guys, we're going to take another look at your tangent graph just so you got a better grasp of this, okay? So here is your tangent graph, and you should notice automatically that there's a big difference between your sine and cosine, obviously, okay? One very big observation is that the tangent has an unlimited range. Unlimited range. It runs from negative to positive infinity, right? Negative and positive infinity. The other thing is that the period, the period, it repeats itself, unlike the sine and cosine of repeating itself every 2 pi radians. The tangent repeats itself, okay, from, if you look just at this first cycle here, from negative pi over 2 to pi over 2, that's a span of pi radians. So the period for the tangent is half the period of the sine and the cosine, okay? Now, as you know, the tangent is sine over cosine. So we're going to look at both sine and cosine, okay? Now that tends to be a little confusing. So the bigger part of it is going to be looking at the cosine, okay? Now why? Because since the tangent is sine over cosine, as we said, okay, wherever the cosine is 0, okay, wherever the cosine has x-intercepts, that's going to invoke, okay, a fraction with a 0 in the denominator. And of course, a fraction with a 0 in the denominator is undefined. So we find then, okay, the tangent is undefined wherever the cosine is equal to 0, which of course happens at these periodic stops, pi over 2, 3 pi over 2, negative pi over 2, or should we just say pi over 2 plus pi k? All right. And it being undefined, the tangent being undefined at those locations, uh, implies that the asymptote is formed. The asymptote is formed. So we get the asymptotes for the tangent at the location where the cosine is undefined. Okay? So that's one of the big things. All right? The other big thing to take away from the graph of the tangent, okay? The span of the tangent, the period of the tangent, runs from asymptote to asymptote, asymptote to asymptote, okay? With the intercept midway in between, okay? From asymptote to asymptote is a period. What's the period? From asymptote to asymptote. What's the next period? From pi over 2 to 3 pi over 2. From one asymptote to the next asymptote. Okay? Where do the asymptotes occur relative to the intercept? Okay? The asymptotes occur a half a wavelength to the right and a half a wavelength to the left of the intercept. For any tangent, regardless of how we alter that with its period, here's a period alteration with the b value equaling 1/2, okay? What do we observe? Okay, the one consistency we said before, okay? The span of the wavelength is from asymptote to asymptote. From asymptote to asymptote here is from negative pi to positive pi, which is a span of 2 pi. A span of 2 pi, which is the normal period of pi divided by the b value of 2. So the period for the tangent, the altered period for the tangent is, okay, the normal period of pi divided by the b, the coefficient of x. Okay, so if this were a 2, okay, then my normal period would be pi over 2. And again, the consistency, okay, from asymptote to asymptote is a period, okay, a half a wavelength left, a half a wavelength right of the intercept are the asymptotes. Okay, the period now is pi over 2, so pi over 4 left of the intercept, pi over 4 right of the intercept are the asymptotes. Invoking, okay, any kind of phase shift on that, that level of consistency remains the same. Let's say minus pi divided by 2, okay? This, what is my phase shift? Same as it ever was. C over B. C over B is the phase shift in the opposite direction indicative of this sign. C over D. Pi over 2 over 2. Pi over 4 to the right is where I'm moving my graph. What do I move? I move everything. What's the easiest thing to move? The intercept. The previous intercept for just tangent was at 0. The origin, I've moved it pi over 4 to the right. Where's my next intercept going to be? Another wavelength down the line. Okay? From intercept to intercept is one wavelength. From pi over 4 to 3 pi over 4 is one wavelength, which is a span of pi over 2, which we would find, okay, by taking our normal period of pi divided by 2, resulting in the adjusted period of pi over 2. Once we figure how we phase shift this, then we recall a half a wavelength to the right and a half a wavelength to the left are the asymptotes of my tangent function. Okay? A lot is very similar with the cotangent, but we can address that in another video. Okay, that says it pretty much all for the tangent. The only thing we hadn't looked at, okay, are the other values we could put in here. We could put in the A in here and put the slider in for A. Okay, the A, of course, is there is no amplitude with the tangent. No amplitude, please. Amplitude was high minus low divided by 2. The high is infinity, the low is infinity. We can't do anything like that, okay? The amplitude in sine and cosine was an indicator of the range of the function. Nothing we can do to the tangent will offset the range, okay? This value of A is doing what? Well, look, increased values of A result in a slower rate of the graph approaching the asymptote. Okay? Smaller values of A result in a quicker approach to the asymptote. Okay? A being negative, okay, we'll flip it across the axes as is seen here. A, B, C, D tangents is the Desmos link you want to go to explore that a little bit more. Okay? Nothing is altering the range with the A value, okay? Even invoking another change here with a vertical translation, okay, will have no impact on the tangent graph. Put a change that plus, okay? So the B value here invoking a shift upward or downward. You may not be seeing it best here. Okay, let's get that. You can see a little bit better there. Okay, all right. What's happening? Well, obviously we're offsetting where the x-intercepts are, but we are not offsetting the range. Okay, the range is still from negative to positive infinity. And okay, moving this up and down along the y-axis is not offsetting where the asymptotes are. And of course, where the asymptotes are is where the function is not defined. Okay? There's tangent. That's just about everything you'd ever want to know about tangent. Okay? And I'll try to get some other videos on the other secondary trig functions, those being cotangent, secant, and cosecant. Okay, there you have it.